In today's video, we're going to talk about game engines, specifically why you shouldn't use Unity and why Godot may be a better option for you. The reasons I will be talking about are in-engine reasons, so I'm not gonna talk about that it's open source or that it receives constant updates. I will be focusing in daily use advantages. As you're aware, game engines play a vital role in game development, serving as the foundation for creating exceptional games. However, selecting the appropriate engine can be an overwhelming task. So I've created this video to assist you in making an informed decision. Unity, a widely recognized game engine holding more than 50% market share globally, is known for its user-friendly interface and cross-platform capabilities. But is it truly the optimal option for your game development requirements? Today I'm here to propose that Godot, a newer game engine that is gaining popularity, may be a superior choice for many developers. Now let's start. To begin, let's talk about the installation process. In Godot, installing is very simple. You just go to the official website and then you can click here, it says download latest, you click there and then you can here select the platform in which you are. I am currently on Windows, so I could download here the version for Windows, but I could just scroll down a little bit and I will find here Android, Linux, Mac, etc. So to download Godot, I will just click here, and as you can see, my downloading has just started. And as you can see, it took like 2-3 seconds. Then to open Godot and to actually finish installing Godot, I will just have to extract everything here. And I will have my version of Godot, in this case 4.0.3. Now I could just double click this executable file, and in a matter of less than a minute I will have Godot installed and ready to start creating any project. Another thing very important about this is that you don't have to install any other code editor, as Godot has a built-in code editor. Of course, you can install, for example, Visual Studio or Visual Studio Code and use it in Godot, but by default no other code editor is needed. Then to download Unity is a bit more complicated and will take more time and space, because as you can see, Godot here is only 110 megabytes. But to download Unity, we actually have to download firstly the Unity Hub. Then in Unity Hub we have to download a Unity version, and then we will need to download a code editor. So in order to run Unity we would need 3 programs: Unity Hub, Unity Engine, and any code editor of your choice. But if we want to use Godot, we just have to download Godot. So once you have downloaded a Unity Hub, which is very simple to download, and you will go here to where it says installs, then here we will click install editor, and here you have all the long-term support versions that are the recommended version, as you can see, or we also have other versions. The size of just the Unity engine is above 13 gigabytes, and we also have to consider Unity Hub and the code editor. Let's now talk about loading times. Imagine creating and opening a project in like 5 seconds or even less sometimes. Well, that's something that is only possible in Godot. You don't believe me? Well, let's create a new project in Godot. I will name it versus Unity, for example. I will create a new folder in this project path, select the renderer, and I will click create and edit. It's loading. Okay, 3, 4, 5, and you can see in 5 seconds we've downloaded Godot. Well, let's now do the exact same thing, but in Unity. I will click create new project. I will click here a 2D template, but of course you can select here. You have lots of templates here, so I believe that if we create a template of 3D, it will take more time than creating a 2D template. But anyway, let's stick with 2D. And in project name I'll put versus Godot. I will leave that location and I will click create project. You will see this will take like 1 minute, 1 minute and a half, even 2 minutes. So it's of course a lot more than Godot. So I will just speed up the video and leave a timer on the screen. Okay, that was 2 minutes and 10 seconds or something like that. So if you think this is because my PC, I will show you something. I have a Ryzen 5 and I also have a GTX 1650, so I have a pretty good hardware, and although despite that it took a lot. Now that we have both engines open, I would like to compare their interfaces. Well, of course this is very personal and there is no fact here that will tell us, okay, this interface is better, the Unity interface is better or something like this. But something that is actually a fact is that in Godot you have less windows. What I mean by saying windows, for example, here on Godot we have scene, import, file system, inspector, node, history, and that's all that we have. Well, we may have here the output, the debugger, the audio, the animation, the shader editor, and I believe we can also have more windows. But here, for example, if Unity in the Windows settings, as you can see, we have a complete tab of just windows we can open. So personally, when I look at this and I see all these windows I can open, it like blows up my mind, and it's maybe difficult to understand what these all windows do. But anyway, that's just an opinion. And both interfaces, I believe, are very good interfaces. They can be easily understood by anyone. But as I told you, when I started with Godot, something that I really like was the interface. I don't know why, but I believe this interface is much more useful, much more easier. But when I started with Unity, interface was like difficult. I don't know why. So I believe in this point there is no fact, it's just a matter of opinion, and you should try, see both and see which flow you think is better. Well, now let's actually talk about the hierarchy system of both, and here, yeah, we have a lot of differences. So in Godot we have nodes. As you can see, we have a node for literally anything. We can create, for example, node 2D, we have animated sprite, we also have normal sprites, we have a kinematic body. Well, now it's called character body, but in Godot 3 it was a kinematic body. We also have the collision shape. So as you can see, everything here that you wanna add is a node. But in Unity this is quite different. We have, for example, 2D objects, and but usually what it's used is, for example, if we want to create a player, we create an empty game object, we call it player, and then here inside our player game object we add the things we wanted to have. For example, we may add a sprite renderer, and we may add here an image, and then, for example, we will add here the collision, and everything would be inside of our game object. Well, in Godot this is very different, because, for example, let's create a character body 2D. Well, as you can see, we can't here add any component or anything. If we want to add a sprite, a collision, or anything, we have to add other node inside of our node. So this is, for example, if you want to create a sprite to render images, okay, sprite 2D, nice. And here in texture we will click load the icon of Godot, for example, and then here we can add a collision shape 2D, nice. And here inside our collision shape we have to define a shape. In this case I'm going to create a rectangle shape, and I'm going to make it a little bit bigger, okay, like this and like this and like this. So in Godot, to create a basic player we will have this hierarchy system, but in Unity we will have a unique game object with a lot of components inside. Again, here is very important your opinion, but well, I believe it is more organized having separated game objects, because also, for example, here in our player we just have a sprite renderer and a box collider, that's all. But then I will need to add a script, maybe I will need to animate it and do a bunch of other things. I will have like to scroll all down to look up to the component. But here in Godot, for example, if I would like, I don't know, to animate, well, not to animate, but for example, to add a line 2D, and what this does is basically a trail renderer that in Unity, for example, if we add here a trail renderer, as you can see, everything is a component. So a trail renderer, what does, well, we don't have a sprite renderer, so we should firstly put here a sprite renderer. So this is a trail renderer, as you can see, but what I want to explain here is that everything is a component. So for example, you are programming, maybe you are adding scripts and all your inspector window is full of components. I know you can use this button and do this, but anyway, I believe the system, the node-based system of Godot is much better. Also because in Godot you have these icons, so when you have a very big scene with a lot of things, having that icons are very useful from differentiating objects from others. Again, Unity is not bad if we compare it to Godot. Again, your opinion is very useful here because there is no fact, but I would say that for lots of people I've watched in YouTube, they mostly say that the node-based system is more organized. In my opinion, when I started in Godot, the node-based system was nice, was very nice. Then I switched to Unity, and although this system is very good, I mean the system that Unity has, I couldn't understand it a lot, whereas the Godot node-based system was very easy to understand. Now let's actually code something. In order to code, I will firstly save this scene with the player, and to this player I'm going to attach a new script with an object empty template, okay? Then in Unity, well, I would also like to make the object bigger because it's very small, maybe something like this. I will create a new script, create C# script, and here I will name it a player movement, for example. I will wait until it compiles because, as you can see, anytime you create a script you have to wait until it compiles, and also any change you make in the script, it doesn't matter if it is a line of code or 100 line of code, you have to wait. So as mostly any engine, you have two, let's say, main functions. One that is called when you start playing the game. In Godot, this is the function ready. So I will print here hello, and I will play the game and select the current scene of my player, and as you can see we have here the message hello. Well, then we have other function, I will erase that. We have other function that is called process delta, and this function is called every frame. So if we put here print hello, we will see the message printed as you can see a lot of times. Of course, in Unity we have these two functions as well, but they have a different name. In this case, the function of ready, called in Godot ready, in Unity is called start, and then the function of process delta is called here update. I will not print something because you have already seen the behavior in Godot, it's the exact same thing. Also here about the code, we can see a bunch of differences. Firstly, when you create a script, you will, if you haven't changed the template of Unity, if you want to change the template of the script of Unity, you have to go to your file explorer, to the installation path of Unity, and then from there you have to change the template, and that's very difficult. Well, that's not very difficult, but if you are a beginner and you just want an empty script template that I believe is the most used one, you have to go to File Explorer and do everything I talked about before. Whereas in Godot, you just, when you create a script, you select object empty template, and that's all. Also here we have some namespaces, we have here some classes, we have things that can be private, that can return a value. So if you are a beginner, this can be a bit difficult to understand at first. Of course, private and public things are very easy to understand. but I'm considering people who have never coded before and they installed Unity, they tried to code something and they see this here, they see this public class monobehavior, what's this, and they have to research a lot in order to just code a couple of lines of code. Whereas in Godot, the object empty template is like this. You only have one line of code, which is super easy to understand because it extends character body 2D, and this is the type of node which inherits from this class. Now I will copy and paste in both a movement system, a very basic movement system, and we will see the differences. So this is the code to make a movement system, a very basic movement system in Godot. This code is from the official documentation of Godot. Then firstly, we create this variable which will store our movement speed. Inside our process delta, we create our actual movement function, in which we basically modify a vector depending on which key the player is pressing. Then if we are actually moving, we will normalize this velocity vector. I will explain this just in a minute. And then we'll just modify the position based on our velocity and on the delta to make it move at the same speed in different frame rates. And this is the final result. As you can see, a very smooth movement system. The thing of normalizing a vector is that if we actually are pressing, for example, D and W, the movement would be like weird, or it will be moving faster if we're moving diagonally. So in order not to use this normalize, we will have to delete it, and then also we'll have to multiply this by our speed. So now when we play, we can see that, well, it seems to be working fine if we move side to side, but if we move diagonally, as you can see, the speed is so much faster. So you can see side to side diagonally. That's why if we normalize the vector, that thing is not gonna happen. Pretty clear this code, right? In Unity, one of the best ways of moving an object and then to be able to actually detect collisions. First, I'm going to delete this tray renderer because I'm not gonna be using it. I'm going to add a rigid body 2D. A rigid body is basically a component which allows us to work with physics and collisions. And I'm going to turn off gravity scale, and I'm also going to freeze the rotation. Then in my player movement script, I will type some code. So we will need our rigid body. I talked to you before, a variable which will store our speed, and the fix update method. And this method is used to things related to physics. As I told you, rigid body is directly related to physics. That's why we use our method. And I believe one of the big differences here is that we have this thing here, input.getAxisRaw. It returns -1 if we are pressing A or 1 if we are pressing D, and this value can be directly used to move our rigid body. The same thing happens with the vertical raw, which returns 1 if we press W, or S, or -1 if we press S. Then we use these two variables to create another other variable of type vector2, which will store our inputs, and will multiply this value by the speed. Something important I forgot is that we have to actually normalize our vector because of the fact I told you before, and then we modify the velocity of our rigid body based on the movement. So as you could see, in mostly every area there is something very important in Godot which makes it nice. It's simple. From having an easy installation process with few steps to having a unique and incredible node-based system hierarchy system makes it a worth option for beginners, but also for more experienced developers as well. I believe that is the most important advantage. On the other hand, Unity is also a phenomenal engine and one of the most used nowadays. For example, Fall Guys, Pokemon Go and Cuphead were developed with Unity. Choosing an appropriate engine is vital for your purposes, but consider that both are great engines and are capable of creating huge things. So you should stop hesitating about which engine is better and just focus on actually creating a game. If you wanna start creating games, I will leave in a complete playlist on the description, and if you wanna see more reasons why Godot is unbelievably good, watch this other video about Godot as a life changer, link in the description as well. There are a bunch of other things we could compare about these engines, so leave a like and subscribe if you wanna see part 2 of this video. Thanks for watching and see you on the next one, bye bye.